Hello class and welcome to, just let me minimize this. Hello class and welcome to lesson 5.4a, the CAST rule. We'll be spending 2 lessons on this topic just because I think we need to develop a good understanding of this since it's a new topic and wasn't previously discussed in your grade 10 class. All right, so from last day, we developed the CAST rule. And just beside the CAST rule, I'm going to put your quadrants in. Just to remember, this is quad 1, this is quad 2, this is quad 3, and this is quad 4. All right, and based on the CAST rule, C-A-S-T, this tells us when the trig ratios are positive. We could also argue, ladies and gentlemen, for example, if we take a look at quad 3, this tells us that tan theta is positive. But if tan theta is positive, then what must be negative? We could argue that it also tells us that the sine theta is negative and the cos theta is negative. So again, it really the CAST rule tells us when they're positive, but if they don't appear in that quadrant, then they will be negative as well. All right, so we're going to use that information today to help us solve some problems. So first of all, it says, if sine theta equals 0.7859, find theta if it's between 0 and 360 degrees. First thing we need to note, folks, is taking a look at sine theta. Sine theta, look at the value of it, 0.78, is positive. Okay? So what we need to do is say, therefore, what quadrant is sine positive in? So we go up to our CAST rule. We know it's going to be quad 1 and quad 2. Okay? So there could be 2 possible answers for this. Okay? So the first thing I'm going to do is draw my first angle, which is in quadrant 1 because that's always the easiest one. Why is it the easiest one? Because the reference angle is always going to be equal to the principal angle. So let's figure that out, okay? Let's call that theta 1 since we're going to be finding 2 answers here. Okay? How do we go to find that, folks? We already know that sine theta equals 0.7859. To find the value of the angle, remember you got to use your inverse buttons in your calculator. So theta, which we're going to call theta 1 in this case, equals the sine inverse of 0.7859. So plug it in your calculator, ladies and gentlemen, and you're going to get theta 1 equals 52 degrees. Now that's what we call the reference angle because its initial arm is at the x-axis and it goes up. So the first angle that we're interested in here is theta 1. So that's the first angle that has that value. But controversially, ladies and gentlemen, we also know that sine theta is positive in quadrant 2. So what I'm going to do, folks, is I'm going to draw the same type of angle. So this is theta 1. Okay, we know now that that's 52 degrees. So to get my second angle, which I'm going to call theta 2, I start from my initial arm and I go over here. So this is what we're going to find, the second angle, which is theta 2. How do we calculate theta 2, folks? Theta 2 equals 180 degrees. Subtract the 52 degrees, which is your reference angle. Okay? So subtract those, and you're going to get that theta 2 equals 128 degrees. So therefore, the answers for theta, theta equals 52 degrees, and you could say theta 2 equals 128 degrees, or you could say, therefore, the angles that fit the situation are 52 degrees and 128. You could say, hey, Ms. R, fine and dandy, but what does that really mean? Well, if you take your calculator and go sine of 52 degrees, plug in your calculator, you're going to get an answer, and it's going to be the same as if you'd plug in sine of 128 degrees. Okay, and that equals 0.7859. because the cast rule will allow us to have two answers that represent the same. So the sine of the first theta equals the sine of the second theta. Okay? That's going to be valuable information when we take a look at our future lesson, part 2, which is next class. Okay, folks? So just the idea that theta 2 and theta 1, when you plug them into your calculators for sine, cos, or tan, will give you the same values. All right, let's take a look at example 2 here, folks. Example 2, and again, we've changed it up. This angle is called alpha. It's one of the Greek letters. So if cos alpha equals 0.8192, find alpha if alpha is between 0 and 360 degrees. First thing we have to realize or take a look at is the value of this cos alpha positive or negative? It's positive. Okay, so what quadrants will we in? So if cos of alpha is, sorry, my fault, let's make that better, is positive. Therefore, what quadrants are we in, folks? We're going to be in quadrant 1 and quadrant 4. Okay, everybody good with that? All right. So I'm going to draw my first angle, which is alpha 1. That's in quad 2. I apologize, quad 1. Okay. So if I do my quad 1, 2, 3, and 4, and if you want to put the cast rule on there just to see, it's C-A-S-T. All right. So alpha 1, folks, we can calculate from the information given. So alpha 1 equals the cos inverse of that value, which is 0.8192. So plug that in your calculator, ladies and gentlemen. Okay, and you will know that alpha 1 equals 35 degrees. And again, folks, that's your reference angle. Okay, so we now can draw our first angle that suits the situation, and it is 35 degrees. Now to get the other possible solution, because cos is positive in 2 quadrants, we're going to draw alpha 1 here in quadrant 4. We know this is 35 degrees. So to get our second angle, we're going to start here, go all the way around to get there, and that's going to be alpha 2. Okay, so alpha 2 in this case, folks, equals 360 degrees. Subtract the 35 degrees or your reference angle, plug it in your calculator, and that's going to be 325 degrees. So therefore, alpha, for fitting the situation between 0 and 360, equals 35 degrees, or it can equal 325 degrees. What does that really mean, folks? In terms of this problem, if you take the cos of 325, that equals the cos of 35 degrees. You plug in your calculator and check. That's both those answers are going to equal 0.8192. Awesome. Let's take a look at a different example, okay? So in the first 2 examples, we gave you the values of the ratio. Now we're going to use this information of the cast rule to help us find what's called the equivalent expression. Okay, and we're going to use what's called the related acute angle. That's the same as your reference angle from last class, if you're wondering what that is. And we're going to state an equivalent expression. All right. So taking a look here, folks, I'm just going to realize that cos is positive in what 2 quadrants, folks? I apologize. Let's back that up. We're not worried about cos yet. We have to take a look. The difference here, guys, is the angle is given. So what quadrant, folks, is 130 in? And you're going to know it's in quadrant 2. So we can draw our angle of 130 degrees. Okay? So that's in quadrant 2. If I just put my quads down, quad 1, quad 2, quad 3, quad 4. Now let's take a look at the cast rule, folks, to help us out with this situation. C-A-S-T. In quadrant 2, is cosine positive or negative? It is negative. So cosine is negative in quad 2. Okay, where else is it going to be negative? Okay, it's also going to be negative, therefore also negative in quad 3. So that's going to help us. Okay, but the first thing we want to do is try to find our reference angle. Okay, because we're going to use a reference angle to help us. So theta is going to be what we're going to find here. So theta equals 180 degrees, subtract 130. So theta, which is our reference angle, is 50 degrees. So that's our reference angle. Okay, so to draw that, now that we know this is 50 degrees, okay, we also have to draw it so that it's 50 degrees in quad 3. So we now know this is 50 degrees. Okay. All right, you can call that theta. Now, if we want to find a matching expression, ladies and gentlemen, we're interested in the angle that meets to this line here. So we start here, we go all the way around to here, and that's going to be what we're going to call, we could call it alpha if you want. Okay, so alpha, which is our equivalent expression. Okay, we're going to find the angle that makes it equivalent. Okay, so to get that, ladies and gentlemen, realize that you take 180 and you have to add 50 degrees to it. Okay, so the alpha in this case is 230 degrees. So when the question says find the equivalent expression, what does that mean? That means that cos of 130 degrees equals the cos of 230. Again, if you plug that in your calculator, ladies and gentlemen, you will get the same value. All right, let's try example B here, and I'll try to make a little bit more room. I know that one's a little scattered. Start off with the angle, ladies and gentlemen. 200 gets us into quadrant 3. Okay, so again, this is our angle, which is 200, which is 200 degrees. Okay, just going to move that up because I'm going to realize in a second. I'm just going to write it up higher. So it's 200 degrees, that angle. All right. So what we need to do is take a look in quadrant 3 and apply the cast rule. Is tangent positive in that quadrant? Yes, it is. So where else is tangent positive? In quadrant 1 here. So that's my first angle. My second angle is going to be right here, which we're going to find in a second. All right. So how do we first find the reference angle? So to find theta, we know that it's 200 degrees. And we've got to subtract 180 degrees. So that's going to equal 20 degrees, guys. Okay, so 20 degrees is the reference angle in quad 3. However, when we move it to quad 1, remember the reference angle equals your principal angle. So this also has to equal what? 20 degrees. So what does this tell us? Our equivalent expression means that therefore tan of 200 degrees equals the tan of 20 degrees. And again, if you plug those both in your calculator, ladies and gentlemen, you will get equivalent expressions. Awesome. Example 4, we got 2 questions, but these are the last 2 questions and we can do these. Just remember, folks, when you read a question and it says determine the exact value without a calculator, exact should lead you to a couple lessons ago where we talked about special triangles. Okay, and remember, it's easy just to draw these triangles. So this is a 1, 1, root 2, and it's 45-degree angle. Okay, your second one, maybe you draw it a bit bigger because it has more information in it. That's a 60, 30, root 3, 2, 1. All right. When you use exact triangles, basically, ladies and gentlemen, you're going to find reference angles that have to either be 30 degrees, 45 degrees, or 60 degrees. That gives you another indication that you've got to use your special triangles. Okay, but that's the reference angle. Notice here in this case, for example, A, sine 225, that isn't a reference angle. How can you easily tell? Is because it's not between 0 and 90 degrees. All right, so let's do that. Sine of 225, ladies and gentlemen, what quadrant is that going to be in? That's going to be in quadrant 3. So you start here, go like this, ladies and gentlemen, and you say 225 degrees. Okay? What we need to find now is our reference angle, which is theta here. So theta equals 225 degrees, subtract 180 degrees, and you will find out that that theta equals 45 degrees, and that's your reference angle. So once we know 45 degrees, ladies and gentlemen, we can then basically do a triangle here. Okay, 45 degrees is that angle, and we can set up our dimensions, which is 1, 1, and root 2. And we can use that to help us find what's called the sine of 225. Okay, so the sine of 225 equals the opposite over the hypotenuse. The thing we need to realize, though, before we take a look at this is sine positive or negative in this category or in this quadrant? So let's just quickly put the cast rule on here. So in quadrant 3, is sine positive? No, it's negative. So I'm automatically going to put a negative down, and then I'm going to say that it's opposite over the hypotenuse. Okay. So what is that going to equal, folks? That's going to be negative sine of the reference angle, which is 45 degrees. Okay? Leave the negative out front. Okay? And the opposite side of that is 1 over the hypotenuse, which is root 2. And then you leave it like that as an exact value. So when they ask for exact value, it's negative 1 over root 2. So again, you have to apply the cast rule to see if it's positive or negative. All right, last example here, folks. Cos of 330. So first of all, let's draw 330 degrees. So from here, we go all the way around to here. Put an arrow. Okay, we know that's 330 degrees. We want to find our reference angle. So theta. Okay. So taking a look at that, folks, theta, which is our reference angle, equals 360 degrees. Subtract 330 degrees. So theta in this case equals 30 degrees. Okay, so what we can do, folks, is we can put in 30 here. Okay, draw a triangle, 90-degree right angle. You should remember beside the 30 degrees is your root 3. This is your 2, and this is your 1. Okay, let's use the cast rule, folks, to see if it's positive in that, and indeed it is positive. So what does that tell us? That cos of 330 degrees equals, and I'm just going to throw it in. You don't need to put it necessarily in, but just make sure you've checked it. Positive cos of 30 degrees. Okay. And when we take a look at the 30 degrees, ladies and gentlemen, cosine of it, if you look at the sides, it's going to be the adjacent, which is root 3, over the hypotenuse, which is 2. Okay, so when it asks for the exact value of cos of 330, that equals root 3 over 2. All right, so there's another piece of the puzzle added on there, ladies and gentlemen. We will continue this next day and build on with this, but for now your homework is page 299, numbers 4, 5, 8 A, B, C, 9, and 15 A and B are challengers. Give them a try. All right, and again, come see me if you need any help. Thank you and have a great day.